Hello, I'm Carly McAvoy. I'm looking at systems of equations, a brief review today of that. I want to look at three different things: solving a system by graphing, by the substitution method and the elimination method, also known as the addition method, and then look at a couple of word problems, one that has to do with investments and one that has to do with acid or mixture problem. When you solve a system by graphing, remember a solution to a system is an ordered pair that solves both equations. So what we're going to do is graph those two equations and then see where they intersect or see if they do intersect. So I'm going to take this first equation and I'm going to find the two intercepts. Whoops, what if x is 0 and what if y is 0? Well, if x is 0, do you see how 2x equals negative y equals 7? The 2x just drops out if x is 0. So if I divide both sides by negative 1, I get y equals negative 7. So I have y equals negative 7, and that's just a little, forget that little mark. And then what if y equals 0? Then I have 2x equals 7 because the y would drop out, leaving the 2x equals 7. Divide both sides by 2, and x equals 7 halves. And I'm going to think of that as 3.5 because it makes it a little easier to graph. So I have the point 0, negative 7. 1, 2, 3, 4, 5, 6, 7. That's my y-intercept. Then I have the point 3.5 on the x-axis. 1, 2, 3.5. So I'm going to try to be careful because it's hard sometimes to solve by graphing. If you don't make a very accurate graph, then you can't tell what the actual solution is. And I just did mine just like I didn't want to do and let the thing slip. But I think it'll be fine. So there's my graph for the first equation. Now I'm going to do the same thing for the second equation. What if x is 0 and what if y is 0? Well, if x is 0, that 0 plugged in there would make that go away. And I would get negative 3y equals 7. And then dividing by negative 3, I get y equals negative 7/3, which is negative 2 1/3. And I want to use that because it's a little easier to graph that way. I'm going to think of it that way. And then what if y is 0? Well, if y is 0, then 3 times y would just drop out, and I would get negative x equals 7. And that gives me, when I divide by negative 1, x equals negative 7. So now I have these 2 points, negative 2 1/3. Notice I can't do exactly that. I can be somewhere in there. I don't know exactly where 1/3 is. And then negative 7 for the x-intercept. 1, 2, 3, 4, 5, 6, 7. And now when I draw my second line, I'm going to see if where those two lines intersect. I can see that they will intersect. So I have my point of intersection right here. And it looks like 1, 2 to the x, and then 1, 2, 3. So it looks like my ordered pair is 2, negative 3. Before I box that and go on, I'm going to check it. It's not hard to check. What I'm going to do is say 2 times 2 is 4, and then minus negative 3 is actually plus 3. 4 plus 3 is 7. So it works for that equation. And for the second one, I'm saying negative 2. Negative 3 times negative 3 is positive 9, and negative 2 plus 9 equals 7. So it checks out in both equations. Sometimes in a graph you can be off a little bit and you might get the wrong answer. So that's a way to check it. Okay, so next thing is by substitution. In the substitution method, I write out my equation, my second equation here. Instead of y, I substitute what y equals, which is x minus 3, and then I still have that thing equaling 3. So all I did here was I replaced the y with the x minus 3. That gives me 3x minus 9. Negative x and 3x is 2x. And add 9 to both sides, we get 12. And divide by 2, and we get x equals 6. Remember, that's not the final answer. Our final answer should have a y value as well. So we go back to here and say, well, if x was 6, then y is 6 minus 3, or 3. Again, I can check that very easily. If x is 6, 6 minus 3 is 3. Yep. And over here, if x is 6, I get negative 6. And 3 times 3 is 9. Negative 6 plus 9 is 3. The check is very quick and easy. The third problem is the elimination method. I'm going to multiply both of these equations, or one of these equations, by something. I'm going to multiply the top equation by 2. The reason I'm doing that is so that I can get positive 4y to eliminate with that negative 4y. That gives me 6x plus 4y is negative 16. And then I have 2x minus 4y is 0. I didn't change that one. Add those together, the y's drop out. I get 8x equals negative 16, or x equals negative 2. Now remember, I have to still go back and find the other value. I can plug into any one of these equations. 3 times negative 2 minus 2y should be negative 8. 3 times negative 2 is negative 6. So I get negative 6 minus 2y is negative 8. Add 6 to both sides, and you get negative 2y is negative 2, or y equals 1 when you divide both sides by negative 2. I can check that though. 3 times negative 2 is negative 6. 1 times, what did I do wrong here? Oh, it's positive. No. Oh, this was supposed to be a positive 2y. Dividing by positive gives me a negative. See how when I went to check that it didn't work? That's, maybe you caught that before. It doesn't work. That's why I always say go back and check to make sure. So negative 6 and then negative 1 times 2 is negative 2. And if you add those together, you get negative 8. 2 times negative 2 is negative 4. Negative 4 times negative 1 is positive 4. Negative 4 and positive 4 equals 0. And that is that one. Okay, I'm going to do the word problem separate video just because I think this is getting too long. We'll see you next time.